In the last video of section 2.1, we're going to look at properties of limits. And posted here on the screen are all the different limit properties. Okay, if we have the limit of two functions being added together, that's really equal to the limit of each individual function added together. Similarly, for subtraction, it's the same rule. Our constant multiple rule for limit says if we have the limit of a constant times a function, I can bring the constant out front, find the limit of my function, and then times it by the constant. The limit of the product of two functions is really the product of the two limits of the individual functions. Similarly, for division, provided that the denominator is not equal to 0, as you see here. And if I have the limit as x approaches a of some function to the nth power, I can really take the limit of the function and then raise it all to the nth power, and same thing for the square root. So let's take a look at a couple of examples applying the limits. Okay, so example 1, we're given that limit as x approaches a of a function f is -3. The limit as x approaches a of function g of x is equal to 0, and the limit as x approaches a of h of x is 8. Find the following limits if they exist. So in part A, I want to find the limit as x approaches a of h of x plus f of x. So this is the sum of limits. So this is really the limit as x approaches a of h of x plus the limit as x approaches a of f of x. And now I can substitute in place of this part. I'm going to be substituting in 8. And in place of the limit as x approaches a of f of x, I'm putting in -3. So this answer is going to be -5. In part B, we are doing the limit as x approaches a of a function all squared. So this is really the same thing as the limit as x approaches a of my function all squared. And this is going to equal the limit as x approaches a of f of x is -3 all squared. So this answer is going to be 9. All right, in the last example, okay, we have a constant up top in front of my function f of x, and I have a difference, and this is all tied together within a quotient. So this is really going to equal the limit as x approaches a of 2f of x divided by the limit as x approaches a of h of x, subtract the limit as x approaches a of f of x. And now I am going to apply the constant rule, which says I can bring my constant out front. And this is really the limit as x approaches a of f of x, all divided by the limit as x approaches a of h of x minus the limit as x approaches a of f of x. And if I work this all out, I'm going to get 2. And the limit as x approaches a of f of x is -3. All over the limit as x approaches a of h of x is 8 minus the limit as x approaches a of f of x, which is -3. And this works out to be -6/11. Okay, let's take a look at some of these same properties dealing with values off of a graph. So now I have the limit as x approaches 0 of f of x times h of x. So this is really the limit as x approaches 0 of f of x times the limit as x approaches 0 of h of x. So looking at graph f, the limit as x approaches 0 of graph f is equal to -1. And the limit as x approaches 0 of graph h is +1, and -1 times +1 is going to be -1. In the second example, this is really the limit as x approaches 0 of h of x divided by the limit as x approaches 0 of g of x, which is going to equal the limit as x approaches 0 of h of x is going to be 1, divided by the limit as x approaches 0 of g of x is 0, and 1 divided by 0 we know does not exist. Okay, in our next example, we are looking at the sum, okay? And we're doing the limit as x approaches -2 of f of x plus g of x. Okay, and some of you might be thinking right away, well, the limit at x approaches -2 of graph f doesn't exist, so therefore this whole thing doesn't exist. And similarly, in graph f, or sorry, in graph g, which is the bottom one here, the limit as x approaches -2, but we have to be careful. So what you have to do is check both sides here. So I'm going to do the limit as x approaches -2 from the positive side of f of x plus the limit as x approaches -2 from the positive side of g of x. If I do that, coming from the left or right side of -2, I get 3. Coming from the right side of -2 for graph g, I get 1. So this limit is 4. Okay. Now I'm going to do the same thing coming from the left of -2. So the limit as x approaches -2 from the left of function f of x plus the limit as x approaches -2 from the left of g of x. Well, coming from the left of -2, it's going to be 1. And coming from the left of -2 in graph g, it's 3. So that equals 4. So therefore, this limit does exist, and this limit would be 4. Okay, let's try the same thing for the limit as x approaches 1 for f of x plus g of x. And notice at 1, the graph is broken for graph f, so we have to do both sides. So we're going to do the limit as x approaches 1 from the positive side of f of x plus the limit as x approaches 1 from the positive side of g of x. Well, from the positive side of f, my limit as x approaches 1 is -1. And coming from the positive side of g, the limit as x approaches 1 is 0. So this limit is going to be -1. Now, if I do the same limit as x approaches 1 from the negative side of f of x plus the limit as x approaches 1 from the negative side of g of x, the limit as I approach 1 from the left of f of x is 2 plus the limit as x approaches 1 from the left of g is 0, so this limit is going to be 2. So these two answers here are not the same. So therefore, we can state that the limit as x approaches 1 of f of x plus g of x does not exist. And in the last example, I'm just going to erase some of this so I got some room to work now. Whoops, this is still graph g. I have the limit as x approaches 1 of f of x times g of x. So again, I have to do the limit as x approaches 1 from the left of f of x times the limit as x approaches 1 from the left of g of x. Approaching 1 from the left on f was 2. And from the left of g was 0, so this limit is going to be 0. And now if I do the limit as x approaches -1 from the positive side of f of x times the limit as x approaches, sorry, not -1, +1 from the positive side of g of x. Well, coming from the positive side of f, this is going to be -1. And the positive side of 0 is 0. So this 2 is 0. So therefore, we could say that the limit as x approaches 1 of f of x times g of x is going to equal 0. So you have to be careful with some of these. Just because the limit may not exist at 1 or at -2 on these graphs individually, the limits of the product of the two functions may exist. So you have to check both the left and the right-hand limit. Okay, for this last section, we're looking at the limits of composite functions, okay? And to evaluate these limits, let's start with the inside, okay? And if we look at the inside here, we have h of x is my inside function. And I'm gonna let, later on, I'm gonna make a substitution, but I'm gonna say let u equal h of x, okay? So right now, I am going to do the limit as x approaches 3 of the inside function h of x. And if I look at my graph of h, the limit as x approaches 3 is going to be 2. So now I'm going to take this 2, and it's going to become the value that x is going to approach when I do the limit of g. So this is now going to be the limit as x approaches 2 of function g of, and I'm going to put in place of h of x, u, and the limit as x approaches 2 of g of u, or graph g, sorry, is going to equal 0. So therefore, the answer for that question is going to be 0. So basically, do the limit as x approaches 3 of the inside function. Whatever that answer is, that becomes what the limit as x approaches 2 of the outside function. So taking a look at this one, I'm going to do the limit. Whoops, sorry about that. I'm going to do the, first of all, we'll say let u equal our inside function g of x. And we're going to find the limit as x approaches -1 of g of x. And as I approach -1 of g of x, this does not exist. Since the limit of the inside doesn't exist, and therefore this limit does not exist. All right, in the next example, okay, again, I'm going to do the limit as x approaches -3 of f of x, and I should have made the statement that we're going to let u equal f of x. So the limit as x approaches -3 of f of x is equal to 1. Okay, so now the limit as x approaches 1 of function h of u is going to equal, well, if we go to graph h, the limit as x approaches 1 on graph h does not exist, so this one also does not exist. Okay, here's some more limits of composite functions, okay, and these ones get a little trickier, okay. So we have the limit as x approaches -2 of g of f of x. So again, I'm going to let u equal f of x, okay. So now I'm going to look at the limit as x approaches -2 of function f. And I'm going to look from the left side of -2, and I'm also going to look at the limit as x approaches -2 from the right side of my function. And if I look, the limit as x approaches -2 from the left of graph f is going to be 3. And it's coming from below 3, so it's really approaching 3 from the negative side, or from below 3, so it's negative. And if you look at, as I approach -2 coming from the right, it's also approaching 3 from below. So therefore, I'm going to be finding the limit as u approaches 3 from the left side of function g of u, which is my outside function here. Okay, so as I approach 3 from the left side of function g, my limit is approaching 1. So you have to take into consideration here with this one, because the answer to the first limit, it breaks or has a discontinuity in the second graph. Okay, you have to consider from what part of 3 are you approaching. So let's try another one here. Maybe it'll make a little bit more sense when we're done the second one. So again, for the second question, I am going to let u equal g of x. Okay, so therefore, first of all, I'm going to find the limit as x approaches 0 of the inside function g of x. And I'm going to approach it from the negative side and from the positive side. When I approach 0 from the negative side on function g, okay, that is approaching 0 from above, so 0 from the positive side. And or sorry, 0, yeah, from here from the positive side. And when I'm approaching 0 from the right, it's also approaching 0 from the positive side. So therefore, when I do the limit of the outside function, it's going to be the limit as not x, but it's going to have to be u. Sorry about that. So this is going to be the limit as u approaches 0. It's going to be from the positive side of my outside function, which would be f of u. And coming from the positive side of 0, this limit is going to be 2. Okay, let's take a look at the next one, and then I'll let you try the last one on your own. But if we take a look at number 3, we're asking the limit as x approaches -2 of g of x. Okay, so again, I'm going to let u equal that inside function g of x. So now I'm going to have the limit as x approaches -2 from the negative side Okay, and the question, oh, I missed the negative, is actually just asking us from the negative side. So the limit as x approaches -2 from the negative side. Okay, if we take a look at that, and we're dealing with function g of x. So as I approach -2 from the negative side on g of x, that limit is approaching from the negative side, that is approaching -2. Which you can see right here. And it's approaching -2 from above, so it's from the positive side. So therefore, to find the limit of the outside function, it's going to be the limit as x approaches, sorry, not x, I always make that mistake, as u approaches -2 from the positive side of the outer function, which is again g of u. So as I approach -2 from the positive side, that answer is going to be 4. So 4 would be my final answer there. Okay, if we take a look at, we might as well do the last one together as well. Okay, so in the last example, we have the limit as x approaches 2 of f of x. So again, I'm going to let u equal f of x. I'll make a later substitution. So right now, let's do the limit as x approaches 2 of function f of x. Well, the limit as x approaches 2 of function f of x, notice the limit, one is coming from the bottom of 2 on the right side, and from the left side it's coming from the top of 2, but they're both approaching a value of -2 from both sides. You notice it's approaching 2 from this side and approaching -2 from that side. So therefore, I want to do for the outer function, the limit as u approaches -2 of function, again, it's the outer function, is f of u. And if I look at function f again and I approach -2, that answer is going to be 3. So you just have to be careful with some of these composite functions. Do the limit of the inside, and then whatever that limit is, that's the limit you're approaching on the outside. And if you're approaching the inside limit from both values above, then we take the positive branch. If you're approaching from both sides, above and below, you just have to do the limit at -2. So you have to be a little bit careful with some of these composite ones. All right, we take a look at one more example. This is from the AP Central website. Again, we're looking to find the limit as x approaches 0 of f of x. So again, if we let u equal the inside function f of x, and let's figure out the limit as x approaches 0, first of all, of f of x. And I'm going to approach 0 from the left, and the limit as x approaches 0 from the positive side of f of x. Coming from 0 on the left, I'm approaching 2 from below. And as I approach 0 from the right, I'm also approaching 2 from below. So therefore, in the next question, or next part, I'm going to do the limit as u approaches 2 from the left of f of u, because my outside function is f. As I approach 2 from the left, this answer is going to be 0. So if you want to pause, there's an explanation that they gave off the AP Central website, but there would be your answer. Okay, there is your assignment on page 63 of the AP Calc text, numbers 43 and 44. And we want to look at limits of combined functions and composite functions, a handout, section 2.1. So give those a whirl and see how you do.